So guys, today we are starting the equilibrium of system of forces. So what do you mean by equilibrium of forces? Equilibrium of the forces means the resultant of all the forces, when you sum it up, will be equals to 0. For example, summation of horizontal forces equals to 0, summation of vertical forces and summation of moments because of all the forces should be equals to 0. Okay, you should know what is meant by equilibrium of forces. Next, in order to do the problems, you need to know some of the principles of equilibrium for different force systems. We shall take two examples as such now. Okay, this is called as two force system. What you can see here, two force system are such a force like where the forces are applied towards left and right side. They are trying to pull the body. And what does the two force system says? If a body is acted upon by two forces, then the equilibrium must be in magnitude, okay, equal in magnitude, opposite and collinear with the same line. Okay, the resultant also lies in the same line. The magnitude will be same as of this force and the direction will be opposite. Only the direction will be opposite to the force, rest to the magnitude, and it also lies in the same plane as of the force. Now coming to the three force system. In three force system, you can see the sketch here. The definition remains the same for three force system. Only thing, the resultant must be collinear with the third force. Which is the third force? The third force is F here. Okay, you can see the resultant is collinear with the third force. F1 is equals to F2 and R is equals to F. In order to solve the problems, you must remember few more points also. I have just noted here. If a member AB is subjected to pull, then the body provides resistance R against the external force P. Here, the direction of resistance force R are away from the ends A and B. You can see the force system. Okay, you can read this statement. Such forces in member which are away from ends, then they are in tension. Okay, you can see the forces are away from the member. Okay, point A and B. So they are providing you the tension forces. When it's being pulled, the resistance will be towards the opposite direction, and when they are moving away from the ends, then they will be in tension. Now next, if forces in members are towards the end, you can see these forces are towards the point end. So such kind of forces are called as compression forces. Then they are said to be in compression. Okay, they are moving towards the point. Next, now these all metals like strings, cables, wires, ropes or chains are always subjected to tension only. Okay, all the cables you see, the strings, wires and all those things will be always in tension. There is no point of compression in those kind of members. Next, if a string carrying freely hanging load on one side will be in tension. If such string passes round a frictionless pulley, you can see the sketch. See, if such a string is passing through this is a pulley. Okay, it is frictionless, there is no friction happening, so whatever the load will be there, the same load will be acting as a tension even in this string. Okay, then the tension on the other side of the pulley, okay, this side I'm talking about, the tension on the other side of the pulley remains same as shown in figure D. Okay, whatever this load will be there, so will be the tension load in the cable. Okay, so I have written here T is equals to W. So the last point is reactions are directed towards the centroid of the body. Okay, the reactions are always directed towards the centroid. You can see the sketch, small sketch I've drawn. The reaction is always at the center. They will be acting at the center. For rectangle it is also center, and for circle also it is acting at the center. Now let's move to the problems. You can see the question number 1. You can have a snapshot of this question. Two cables are connected at A and C as shown, and a force of 20 kilonewtons is applied at B. Okay, if you want to have a pictorial representation of the problem, you can see here and you can correlate with the question. Okay, the question is here. Two cables are connected at A and C as shown, and a force of 20 kilonewton is acting. Okay, here it is acting, is applied at B. This is the point B. Determine the forces in the cable along BA and BC. They are asking what will be the tension forces acting in the cable AB and BC. Okay, so now we shall move to the problem. So here is the sketch. They will be giving you the sketch, only the sketch they will be giving. These two we have drawn it in order to solve the problem. Okay, now you can see what is an angle made, 30 degree, this one, this force, and this will be 45 degrees. See, as I said, these are the cables. What I said, cables will be carrying only the tension forces. Okay, when cables are carrying only the tension forces, you can expect only the tensile forces acting in these two strings. Okay, only thing what you have to do, you have to understand in which directions they will be acting. Okay, if it is pulling up, pulling down, what you can expect, in order to keep this body under equilibrium, there should be an upward pulling force. Okay, this is the force which is acting immediately from point B along BA. Okay, so there will be tension forces in this direction. From A to B it will be acting downwards, from B to A it will be acting upwards. Okay, this is trying to pull. Okay, these two strings are trying to pull and keep this body under equilibrium to whatever 20 kilonewton is trying to do. Okay, 20 kilonewton is trying to pull it down, and these two cables are trying to pull it up by applying tensile forces. Now this is the free body diagram. What is a free body diagram? You are freeing the body from all the supports. That such a diagram is called as free body diagram. What are the supports? These two surfaces are the supports. Okay, now because of the cables or tension carrying members, cables T1 and T2 will be the tension in the cable AB and BC respectively. Since system is in equilibrium, let's apply equilibrium condition, that is sigma h and sigma v is equals to 0, considering free body diagram of the given problem. Now once we have written these statements, let's resolve the forces horizontally, that is sigma h is equals to 0. Please kindly note, have a snapshot of this sketches. Okay, next, now sigma h is equals to 0. So once you know that the forces will be minus T1 cos 30 plus T2 cos 45. This is all simple. You have these are the basics which you kept doing in the entire problems. Okay, you can see T1, it is making an angle with the horizontal, hence the horizontal component will be cos and the vertical component will be sine, and so as same will be T2. So once you have the snapshot of this, please draw in one of the page if I could solve that. Okay, yeah. So minus T1 cos 30 plus T2 cos 45. After solving this, you'll be getting T2 is equals to 1.22 T1. Now again resolving forces vertically. Okay, the vertical components are this and minus 20. How did you get this minus 20? This is minus 20. Okay, this is the vertical force acting downwards, hence it is minus 20. Once you do minus 20, you just transfer it to the RHS, you will get second equation. So from 1 and 2, you take this equation and substitute the value of T2 here. Then you will be getting T1, that is 14.7 kilonewtons. It is 14.7 kilonewtons. And then substitute back in the equation 1 to get T2. Okay, your T2 will be 17.94 kilonewtons once you substitute in the equation 1. This is the equation 1. Okay, this was the first problem. Now coming to the second problem. So what is the second problem? Find the forces in all the wires AB, BC and CD. Okay, where are the AB, BC and CD, and the load W1 and the load W1 to keep the system in equilibrium with BC horizontal. Okay, with BC as horizontal, take W2 as 1000 newtons. You can see W2 is 1000 newtons. You just have a snapshot of again of this sketch. Okay, this will be the question given. So you can see what is an angle of inclination made. This is 50 degrees. Okay, so if this is 50 degrees and this is 60 degrees, you can just imagine like with the help of alternate angles where you can again put this 50 degrees. We will see it in the sketch I have drawn again. One more neatly drawn sketch for you people to understand. The system is in equilibrium, that is sigma and sigma v is equals to 0. You can see how this particular sketch has been resolved here. Okay, so again have a snapshot of this. It is very clearly drawn on. So when the loads are applied W and W2, okay, you have tension in the cable AB has T1 and tension in the cable BC has T2 and tension in the cable CD has T3. Okay, so W1 and this is W2 is 1000 newtons. So W1 is what we are supposed to find. Okay, now let us solve this particular joint now. Okay, but joint C, considering equilibrium of joint C. Fine, resolving forces vertically, sigma v is equals to 0. Fine, when you consider this joint, this is our joint C. Now you can see, you can correlate this. Okay, this is the tensile force acting upwards and this is towards leftwards. What is this trying to do? When it is being pulled down, so in what direction the forces act in order to keep this under equilibrium? Definitely they have to act in left and they have to act in upwards only to keep this point C under equilibrium when it is being pulled by 1000 newtons downwards. So that is what the directions this indicates. Okay, these are the tensile forces. So when you resolve it vertically, you will get see, you have 1000 newtons minus 1000 because it is acting downwards, and when it's been resolved as vertical component, it will be T3 sine 50 because it is making an angle with the horizontal. So the horizontal vertical component will be sine. So T3 sine 50 minus 1000, you will get T3 1305.4 newtons. When you resolve it horizontally, you will get minus T2. Okay, minus T2 because it is acting leftwards. Okay, left is negative, right is positive. Okay, for horizontal component, plus T3 cos 50. Why T3 cos 50? Because there is a horizontal component of force T3 making an angle 50 with the horizontal. Okay, so your T2 will be 839.1 newtons. So once you do that, you will be moving to joint B. Okay, joint B of what? Joint B of this force. Okay, joint B. Now you can see 1 2 3. So there are 3 forces here also. So the direction of forces will be this. You can draw the sketch. Okay, your T2 will be acting in the right direction. Okay, because you had got T2 in positive value. Okay, positive, you have to apply it here. You T2 got it in the while solving where for resolving forces in the previous steps. Here it is, your T2 is 839, which you got it in the positive. So here you after solving this particular joint, you got T2 value which is positive, hence you apply the T2 value here to get the further W1. So resolving forces horizontally, sigma h is equals to 0. There is one horizontal force which is acting rightwards, and it is 839.1 minus the horizontal component of the T1 will be T1 cos 60, but it is acting left direction, hence it is minus T1 cos 60. So T1 will be 1678.2 newtons. Now resolving forces vertically, what all vertical forces you have to find this W1, which is acting in the downward direction. They have given it in the question. So minus W1 plus it will be acting upwards. So T1 sine 60. Okay, minus W1 plus T1 sine 60. W1 is equal to T1 sine 60. So when you put the value of T1 in this equation, you will get W1 as 1453.36 newtons. Thank you.